where we'll talk about partitions and boards. We'll first have a look at the ESP32 then we'll go on and see what we can do with the ESP32s3. That will lead us to creating a new file just to handle the S3 boards we've got, as well as being able to add into the IDE definitions for the new boards for this project. So with ESP32 partitions, it's quite easy. You select the target module such as the ESP30 you then go into the IDE tools menu and you see a whole lot of partition schemes that are available. In the previous project we used ESP32 module, and the problem with using that is when I go down to tools and I look at partition schemes, these are the only partition schemes that are currently available, and none of these, there is one for a 16 megabyte flash, 16 megabyte flash, but again that doesn't support OTA, this doesn't support OTA, and it doesn't use all the 16 megabytes of flash. So there's no way that any of these are actually suitable. And what we find as a result of all of that is that the partition information for an ESP32 module with 4 megabytes of flash has an arrangement like this. So it's got, if it's to support OTA, it has 2 app partitions, etc. And it has some storage space for handling spiffs. And you see here that a maximum app partition handling OTA is only 1.3 megabyte, and the spiffs is 1.4 megabyte, and we're using a 16 megabyte flash, and that's really not a good way to handle 16 megabytes. So after having a look at the options currently available in the Arduino IDE, we see there's no real support at all for a 16 megabyte S3 chip that we want to use. There are a few existing board definitions, but they just don't work with the S3 chips that we're using. So the bright idea then is, let's make a new partition file for this project to define it, use that in the project. Also make board definitions for each of the boards and add them to the IDE and ESP32 core. So the idea behind all of this is, let's create a new partition for the project. We save it as a .csv file, we copy it to the ESP32 core partitions folder, and we copy it into the existing project folder for this project. Here we have the default CSV board definition partition information. That's what we have, but we want one that looks like this, and I'm going to call it N16R8_OTA.csv. So this supports 2 app partitions where we can handle the code for the application, so it handles OTA. These are significantly bigger than the previous app partitions. This isn't the scale, by the way. Has huge increase in data storage, so this is going to be suitable, looking out into the future as well. In terms of making the partition file, it's a CSV file, common delimited data, which is arranged as a series of rows and columns. So I'm using the Excel spreadsheet to do this. Could easily be created in a text file, but then just separate each of the fields with a comma. So we've got the MVS partition, which is necessary, no choice on that. We've got the OTA data, no choice on that, but we've got 2 app positions. We've got a spiffs partition, actually it's little FS, but we call it spiffs, and a core dump, which you must have if you want to use the exception decoder. So that's what we've got. So we're going to end up putting this thing into the ESP32 core, and we're using 3.37 I think we're using now, into the Partitions folder, and see this file here, N16R8OTA, and that's where it will go. So the goal is to copy this particular file here into the ESP32 core 3.3.7 Partitions folder. So to do that, we go and that little personal icon in Windows, and here we are, and what we need to find is we want to go to the app data folder, we want to go to local. After local we want to go into Arduino 15, after that packages, after that ESP32 hardware 32, 3.3.7 is the core folder that we want, and we'll just go into there again, and in the core I think it's tools from memory, tools partitions, and in there we want to paste this file. So we copy that and we drop it in here, and I'll just overwrite the existing one because I've already done this, and there we go, that's the partition information already done. Well, we can't access this partition file, or one more step to go, sorry. In the firmware folder, we also have to paste it. So you see it here as well. I've already pasted it. Here we are. And this is the current firmware. And I'm looking at the boards 337 folder. And in this folder, there are a number of files. I've got the original board file here from previously, etc. and other stuff. Partition folder we've already discussed. This boards.robert.txt folder, file, I need to open this up, and so here it is. We've got a whole lot of stuff in, okay. And I also want to copy all of this into the existing boards folder, and I'll do that now. So let's go back. I need to access my personal folder because I've got to access the core data. Go into app data, go into local, go into Arduino 15, we want packages, we want ESP32, we want hardware, ESP32, and notice this is the 337 folder of the ESP32 core. I'm going to go in there, and there's a file called boards.txt file. Right? So that file, that's copied and paste it back in, and I want to rename this to boards.org. If anything goes wrong, of course I can recover it. Right, let's open up this boards.txt file, and here it is. This is all the stuff, and I want to go right down to the absolute end. Each board definition is separated by these long lines. So in here now I want to paste all the boards that I created, and so I'll just select them all like that, and I'll paste it back into here, and then I want to save this file. Let's save the original boards file, and I'll drop out of there, and in here I'm still back in this 337 folder of the core. If I open that up now and I scroll way down to the end, I can see that this defines a board there, and these are the boards that I had created to put in there. So that's great, we've done that. What's next? So I've connected up my target board and all we need to do is load Arduino IDE and use those target boards in the actual program. So this is what we'll do. So we'll switch into here. I currently had this as ESP32 dev module just for purposes of illustration. And to select, now I know that this board is for the board that I'm using, it's a TZT board. How do I know that? And let me just drop out of here and go to config. Focuser TZT. See, I've enabled the ULN 2003 version for this board. So now I'm set the target board to be that. So I'm going to search for a board. I'm going to type ESP32s3, and this is N16R8, so I'm going to type N, and notice it, it's selected the TZT board. So we'll have to do is, let's just do that again, ESP32s3 N, and it's ticked, so we're ready to go. So this changes to ESP32, and if I have a look, watch this, it's got the correct board, it's got the correct CPU frequency, it's got all the options disabled properly, its flash size is 16 megabytes, which is correct because that's the chip I'm using. And notice it, partition scheme, there's only one, the ESP32N16 with little FS and OTA. So it's, by selecting that board, all these parameters in the tools menu get set correctly. So there's no chance of you accidentally selecting the wrong partition. So that's pretty cool. And if we wanted the other particular board, notice how I typed in ESP32s3, ESP32s3, and the next letter I typed it was N. What happens if I'm not using the TZT board, but for example I'm using a dev kit board? Well, D for dev kit, notice it, and if I choose this, you can program all the dev kit boards. So that's pretty handy to have. And I should be able to turn around and just compile this without issue. Alright. So I've asked it to do the verify mode, which verifies that all the compilation of this actually works, and it's going to generate the correct code. So we'll leave that running. Right, so the verify has actually finished successfully, and because we've got these two lines, so this is the amount of the sketch program that takes up 20% of program storage space, and the global bars are using 1% of the available space. Now this output window, first thing it does, it tells me the fully qualified board number is ESP32s3 S3 N16R8, and that's the board that I selected. So I know that it's generating code for the correct board. I know that this is using version 3.37, alright, and I know also that it got this partition file, which is the one we wanted to use. We know that that's also using the correct partition file. So all of this is good and is what we would expect.